So in this video, we'll be focusing on two new key components that are related to a parabola called a focus and a directrix. And by the end of this video, you'll be able to explain what these two values represent, and you'll be able to identify them when looking at a parabola visually. So the easiest way to define and get to understand what the focus and directrix really represent is by taking a look at a couple of definitions. So we're going to start here by looking at the definition of parabola. So here it says a parabola, and you should know at this point that the parabola is the shape that a quadratic graph makes when it is graphed. But in this case, we're going to define this word a little bit differently, because while it is the shape of a quadratic, it also can be defined as the set of all points x and y that are equidistant, which this means the same distance, from a fixed point called the focus and a fixed line called the directrix. So what this is saying is that if we pick any point on our parabola, so say I picked this point right here, it's saying the distance from this point to the focus and this point straight down to this directrix line. So the distance to the focus point and the distance straight down to the directrix line are the exact same distance. So hypothetically, say that this distance was 2, this distance would also be 2. For this particular graph, that's not accurate, but I'm saying hypothetically, if that was the distance, those two distances would be the same. And then, say we want to look at a different point. Say we want to look at this point here. The focus and the directrix are equidistant again from this point. So this one, say it had a distance of 3, then the distance straight down to the directrix would also be 3. So every point on our parabola is the same distance away from the focus point and the directrix line if you draw it straight down. So that's what the directrix and the focus are. They basically are the same distance away from any point on this parabola. Now, if you want more concrete definitions here, you can see that the focus is in the interior of a parabola and lies on the axis of symmetry. So you can see here that it's on the axis of symmetry, just like this vertex point down here is, and it's inside of the parabola. So it always needs to be inside of the U shape. The directrix line is perpendicular to the axis of symmetry, and you should know from geometry that perpendicular means it forms a 90-degree angle. And this horizontal line that you see is the same distance away from the vertex as the focus. So what's kind of cool here is here you have your focus, here you have a point on your directrix line, and here you have your vertex, and there's a distance in here, and we typically call this P, and the directrix and the focus are a distance of P away from that vertex point. And then as you go to various points along your parabola, all of these points, regardless of which point you pick, it's the same distance from that point to the focus and that point straight down to the directrix. So here we're just going to practice what we just learned and apply it to help us find the missing piece. So it says find the focus or directrix, whichever is missing, of the following. So here in example 1, I can see that I have the focus. Now remember, the focus is equidistant from every single point on that parabola, and the easiest way to find the directrix is to go straight down to the vertex. So I can see here that my vertex is at 0, 0, and I can see that there's a distance of 2 here between the focus and the vertex. So what that means is my directrix line also has to be a distance of 2 away, so it's going to be down here, this horizontal line, at y equals -2. So you can see here that our focus is at 0, +2, and it's 2 units away from the vertex straight up, and our directrix is 2 units away from the vertex straight down, and it occurs at y equals -2. So our directrix that we were missing here would be at y equals -2. Now if I take a look at this next one down here, I can see that I have a directrix here at y is equal to 1. So I can see that it's 1 unit away from my vertex, and that means that my focus point is going to also be 1 unit away, but this time it's 1 unit down because it needs to be inside the U and on the opposite side of the parabola as the directrix. So here you can see your focus point occurs at 0, -1. So that's what we'll put as our final answer. That missing piece of the focus occurs at 0, -1. 1.